All right. System and causes. Chapter 1, Part 3, Neets Module 15. System and causes. To help the technician further isolate with a single problem, maybe with an manufacturer furnace with the troubleshoot with the problem coupled with their equipment table with the way of the A with the isolating with the trouble the area quickly table 1 2 through 1 5 2 1 2 through 1 times some of the torque transmitter with the torque receiver the system and some typical troubleshoot the probably couple the keep of the line with the 2 or more receiver the connected to one with the transmitter with a similar system with the curve with the all receiver the active pop. Trouble is usually in the transmitter of the main both the trouble appear with the one receiver the only with the check of the unit and its connections. The angle of the shown with the table that does not apply with the system and you with the differential with the system and use it with the incorrectly zeroed. Table 2, 1, 2 with the general system. The preliminary actions can be sure with the torque transmitter with the jam physically the torque transmitter slowly in one direction. Turn the torque transmitter slowly in one direction. Observe the torque resistor. The torque receiver. Systems overload indicator lights for the U with the home of the torque transmitter with the setting 1 with the overheat the torque resistor. The torque receiver follows smoothly but reads wrong. The trouble the rotor circuit open or shorted. Table 3. Overload indicator lights with the home and all except for the two opposite with the torque transmitter setting the both the unit with the overheat with the torque receiver that stays at 1 to reading half the time the swing of the abruptly to do opposite with the 1 with the torque receiver that may oscillate or spin. The trouble the stator circuit is shorted. Overload indicator lights units over the hum of the two oppositions of the torque transmitter that by setting both the units that get up the warm with the torque receiver with the turns smoothly only one but direction but in reverse. The short stator circuit is open. Torque receiver reads wrong with the turn back with the file with the torque transmitter smoothly. Unit interconnection wrong with the unit not 0 with the table 1 and 1 6. Table 1 3. Open and shorted rotor. Preliminary action set the torque transmitter 0 degree with the torque rotor smoothly counterclockwise. Turn the torque rotor smoothly counterclockwise. Torque receiver turns clockwise 0 degree with the jerky erratic manner that gets hot with the torque transmitter's rotor is open. The torque receiver that turns counterclockwise 0 to 180 degrees and jerk with the erratic manner the torque transmitter that gets hot with the torque receiver the rotor is open. Torque receiver that turns with the counterclockwise 90 to 250 degrees with the torque is about with the normal motor getting hot with the torque transmitter the fuse below with the torque transmitter rotor is shorted. Torque receiver that returns counterclockwise with 0 to 90 degrees 0 to 270 degrees the torque is about the normal the torque transmitter that gets hot with the torque receiver fuse is blown the torque receiver rotor is shorted. Setting conditions. Torque transmitter with 120 degrees to 300 degrees, but when the torque transmitter is between 340 degrees and 80 or between 160 and 260, the indication overload indicator that goes out of the torque receiver the record read correctly. The overload indicator light is give the hot and hum the torque receiver the receiver 120 to 300 degrees that may swing suddenly from one point to the other. The trouble is the stator circuit shorted between stator 1 and stator 2. The torque transmitter is 60 degrees, 240 degrees, but the torque transmitter is between 280 degrees or 20 degrees or between 120 and 200 degrees. The overlaid indicator goes out over the torque receiver reads correctly. Overload indicator light with the unit that gets caught with the hum of the torque receiver stays at 60 to 240 degrees. May swing slowly from one point to the other. The trouble is stator circuit shorted between stator 1 and stator 3. The stator short is shorted from the stator 1 and stator 3. The torque transmitter is 0 to 180 degrees, but the torque transmitter is between 40 and 140 degrees, between 240 and 330 degrees. The overload indicator goes out with the torque receiver that reads correctly. The overload indicator light for the units gets out of the hum of the torque receiver that stays at 0 to 180 degrees may swing suddenly from one point to the other. The stator circuit is shorted from stator 1 to stator 3. The stator circuit shorted from stator 1 to stator 3. Table 1-5, open stator, setting conditions. The torque transmitter with 150 degrees, 330 degrees, and with the torque transmitter held on 0 with the torque receiver, the reverses are stalled with the overload indicator light with the torque receiver, the move between 300 degrees, 0 degrees in a jerky, erratic manner. Stator 1 stator circuit is open. The torque transmitter with the 90 degrees, 270 degrees, and the torque transmitter is held with the 0 degree, the torque receiver, the reverse of the stall with the overload with the indicator light with the torque receiver, the move with the 0 to 180 degrees with fairly normal torque. Stator 2 circuit is open. The torque transmitter with the 330 to 210 degrees with the torque transmitter 0 degree with the torque receiver, the reverse of the stall with the overload indicator light with the torque receiver, the move between 0 to 60 degrees in a jerky, erratic manner. Stator 3 stator circuit is open. The torque transmitter is 0 with the help of the move slowly counterclockwise. No indication of trouble. Continued. Setting in condition the torque transmitter set 0 degree with the round turn smoothly counterclockwise. The torque resistor indicator wrong turn with clockwise at 240 degrees. Stator 1 and stator 2 connections are reversed. Torque receiver to indicator for the wrong and the return with the clockwise at 120 degrees. Stator 2 and stator 3 or stator connections are reversed. Torque receiver indicates the wrong turn to the clockwise 0 degrees. Stator 1 and stator 3 stator connections are reversed. Torque receiver that indicated the wrong turn for the counterclockwise at 120 degrees. Stator 1 is connected to stator 2 and stator 2 is connected to stator 3 and stator 3 is connected to stator 1. Torque receiver indicator was wrong turns clockwise at 240 degrees. Stator 1 is connected to stator 3 and stator 2 is connected to stator 1 and stator 3 is connected to stator 2. Table 1-7, the wrong stator and reverse rotor connections. Torque transmitter set 0 degrees round turn, rotor turn with a smooth counterclockwise. Torque receiver that indicated the wrong turn with the counterclockwise from 180 degrees. The trouble stator connected with the corrected with the rotor connected is reversed. Torque receiver that indicated the wrong turn with clockwise at 60 degrees. Stator connections, stator 1 and stator 2 are reversed, and the rotor connections are reversed. Torque receiver that indicated the wrong turn with the clockwise at 380 degrees. 300 degrees. Stator 2, stator connections, stator 1 and stator 2 and stator 3 are reversed, and rotor connections are reversed. Torque receiver that indicated the wrong turn with the clockwise at 180 degrees. Stator connections, stator 1 and stator 3 are reversed, and the rotor connections are reversed. Torque receiver that indicated the wrong turn is counterclockwise at 380 degrees. Stator 1 is connected with the stator 2. Stator 2 is connected to stator 3. Stator 3 is connected to stator 1. Rotor connections are reversed. Torque receiver that indicates the wrong turn for the counterclockwise from 60 degrees. Stator 1 is connected with the stator 3, and the stator 2 is connected to stator 1. Stator 3 is connected to stator 2, and the rotor connections are reversed. In a control shift, the trouble may be slightly more difficult to isolate. However, the essence of the trouble is readily indicated when the system does not properly respond with an input order for the control system. The easier okay with the trouble to be with the synchronizing temperature check with the operating voltage. Voltage testing. Any other good way to isolate the trouble in operating with the Synchros system is use the now open operating voltage with the reference voltage of the operation symbol proper that operates for the system indicate with the specific rotor stated voltage for the AC voltage for the mega with the local to okay the trouble the AC voltage with the connection between two stator lead. The voltage should vary 0 to 90 degrees from 0 to 11.8 volts and 26 volt with the transmitter rotate the 0 maximum voltage shall be occur with the following headings. Stator meter connected to stator 1 and stator 2. The voltage reading headings is 120 degrees and 300 degrees. Maximum heading voltage 30 degrees and 210 degrees. Stator 2 and stator 3, 0 voltage heading 60 degrees and 240 degrees. Maximum heading voltage 150 and 330 degrees. Stator 1 and stator 3, the 0 voltage readings 0 and 180 degrees. Maximum voltage is headings 90 and 270 degrees. All right, the rotor voltage should be remain with the constant all time with either 115 or 200, 115 volts or 200 or 26 volts. In the system way with the unit with the color enough to permit the check of the voltage between the rotor 1 and rotor 2 terminal. You with the energy of the primary AC source, the corresponding with the rotor 1, rotor 2 terminal. Any other energy of the primary AC source should be 0 with the exciting voltage of the 115 volt with the 26 volt is above with below the nominal value. Maximum stator voltage will also be above below the normal. Synchronizing tester. Synchronizing tester is easy stated early, usually prominently coding locating device. Defective synchro with these testers are capable of functioning as either transmitter or receiver. When the transmitter is suspected with the defect of the synchronizing tester usually submitted in the plate for the simulate with the action for the tester is the main with the braking arrangement of the tester applied with the necessary friction with the hole with the shaft with the differential position. You can determine whether the transmitter is good with the tester transmitter usually good idea with the only receiver. So not overload with the tester with the tester connected with the plate with the transistor receiver that you detect the output of the transmitter breaker that relieve the line with the rotor to determine the indicator of the transmitter position by for the test respond with the transmitted signal you can determine the torque receiver with the defective of the transmitter output that is incorrect. You should normally have the good working with the knowledge synchronizing system. For further study, assistance apply with the knowledge of the Synchros troubleshooting alignment with the consulting of the following reference following the preventive maintenance check services, PMS sources, the applicable maintenance instruction manual, military hammer, Synchros description, operation mill handbook 225A, March 1991. All right, chapter 1 summary.